Welcome. If you are new to this channel, please subscribe and support. Something just happened on the other side of the universe. Something so powerful, so catastrophic, that it defies everything we thought we knew about the cosmos. It began as a faint, almost imperceptible ripple in the fabric of space-time. A strange burst of energy, so distant yet so intense that it caught the attention of astronomers across the world. At first, they thought it was a mistake, a mere glitch in the data. But as they analyzed the signals, the horrifying reality set in. This wasn't just another supernova or a collapsing star. This was something far more extreme. An explosion so powerful it could wipe out an entire galaxy in an instant. Imagine, for a moment, the sheer scale of such destruction. A single burst of energy, capable of reducing billions of stars, planets, and entire civilizations, if they existed, to nothing but dust and echoes. A cosmic detonation unlike anything we've ever observed, its shockwaves stretching across the void of space like the dying breath of a doomed celestial giant. The numbers defy comprehension. This was no ordinary event. It was something scientists have long feared but never truly witnessed. A hypernova? A gamma-ray burst? Or something even more terrifying, lurking in the dark corners of the universe, Astronomers race to unravel the mystery. One question lingers. Could such an event ever happen in our own galaxy? And if it did, would we even have time to see it coming? For decades, astronomers have been scanning the universe, searching for the most extreme cosmic events: supernovae, black hole mergers, and gamma-ray bursts. These are the violent heartbeats of the cosmos, shaping galaxies and forging the very elements that make up life itself. But nothing in recorded history comes close to what was recently detected. It started with a sudden, blinding burst of energy, a flash so powerful that it outshone entire galaxies for a fraction of a second. The signal was picked up by NASA's Swift Observatory and the European Space Agency's Integral satellite, both designed to detect high-energy cosmic explosions. At first, researchers thought they were looking at a typical gamma-ray burst, the kind caused by the collapse of a massive star. But as the data poured in, it became clear. This was something else entirely. The energy levels were off the charts, unlike anything seen before. Leading astrophysicists at MIT, Harvard, and the Max Planck Institute scrambled to analyze the phenomenon. Theories began circulating. Was this a hypernova, an event even more powerful than a supernova? Could it be the result of two neutron stars colliding, unleashing a storm of radiation strong enough to sterilize entire star systems? Or more chillingly, was this an event never before theorized, something beyond our current understanding of physics? The location of the explosion only deepened the mystery. It came from a distant galaxy, over 10 billion light-years away, meaning it happened long before Earth even existed. Yet, its power was so immense that we can still detect its aftershock today. This discovery wasn't just a scientific curiosity. It was a reminder of the raw, unrelenting violence of the cosmos. A glimpse into the kind of destruction that, under the right conditions, could one day reach us. And that's the question no one wants to ask. Could an explosion like this ever happen closer to home? What would happen if such an event occurred in our own galaxy? Would we have time to react, or would the end come faster than we could comprehend? At first, the signal was dismissed as an error, anomalous data from a distant part of the universe, a mere blip in the endless stream of cosmic noise. But then the readings came in again, and again. The same impossible burst of energy, detected across multiple observatories, each confirming what seemed too terrifying to be true. The Vera C. Rubin Observatory in Chile was among the first to notice it, an unexplainable surge of high-energy radiation coming from a galaxy over 10 billion light-years away. Within hours, the James Webb Space Telescope locked onto the source, capturing something never seen before. A blinding explosion, a firestorm of cosmic destruction so vast it stretched across the very fabric of space-time itself. The intensity of the blast was unlike anything in recorded history. Even from billions of light-years away, its light momentarily outshone every star in its host galaxy. The European Southern Observatory's Very Large Telescope, VLT, and NASA's Chandra X-ray Observatory followed up, scanning the aftermath. What they found defied explanation. The explosion had not only annihilated everything in its immediate vicinity, it had seemingly torn a hole in the surrounding space, sending shockwaves rippling outward with enough force to potentially erase entire solar systems. The pattern of radiation was unlike any supernova or gamma-ray burst ever observed. This wasn't just a dying star collapsing in on itself. This was something else, something far more violent. Astrophysicists around the world began scrambling to piece together what they were seeing. Dr. Amelia Carter, a leading expert in high-energy astrophysics at MIT, described it as the most powerful cosmic explosion ever recorded, something beyond even our most extreme predictions. Dr. Elias Navarro from the Max Planck Institute speculated it could be an ultra-long gamma-ray burst from the merger of two supermassive black holes, an event so rare it had only existed in theoretical models. But even that couldn't fully explain the sheer magnitude of energy unleashed. As data continued pouring in, a darker possibility emerged, one that sent a shiver through the scientific community. What if this wasn't just an explosion? What if it was something even more catastrophic? A cosmic event that had the power to reshape entire galaxies, to trigger chain reactions across the fabric of the universe itself? The mystery deepened. The numbers didn't add up. Something about the energy signature was off, irregular, almost as if the explosion hadn't just happened naturally. But if that were true, then the real question was even more terrifying. What could possibly cause such destruction? And, more importantly, could it happen again? To understand the true magnitude of this event, we need to break it down. What exactly happened? And why is it sending shockwaves through the scientific community? At its core, this explosion released more energy in a few seconds than our sun will emit in its entire 10 billion-year lifespan. Events like supernovae and gamma-ray bursts are already among the most extreme in the universe, but this was different, orders of magnitude more powerful. The best comparison scientists have? A hypernova, a rare and catastrophic explosion that occurs when a star at least 100 times the mass of the sun collapses into a black hole. When this happens, it releases twin jets of energy at nearly the speed of light, cutting through space like cosmic death rays. But even a hypernova doesn't fully explain what was detected. The energy signature of this event was irregular, its afterglow lingering in a way that defies standard models. Some astrophysicists believe it could have been triggered by the collision of two supermassive black holes, a cataclysmic event that distorts space-time itself. When black holes merge, they don't just create a powerful shockwave. They send ripples through the very fabric of reality, known as gravitational waves. Others propose an even wilder theory, a failed supernova, sometimes called a pulsational pair instability supernova. In this scenario, a massive star tries to explode but instead collapses inward, releasing an unfathomable burst of energy before disappearing into darkness. Imagine lighting a stick of dynamite only for it to collapse inward instead of outward. Except, on a cosmic scale, with enough force to vaporize entire solar systems. And yet, there are still mysteries. Some researchers suggest that this event might be tied to something we barely understand, dark energy or even exotic physics beyond our current models. Could this explosion have triggered a ripple effect across the universe? Could it be connected to phenomena we haven't yet discovered? For now, all we know is that this event challenges everything we thought we understood about the violent, chaotic nature of the cosmos. And if it could happen once, could it happen again? And more importantly, could it happen here? But here's the part that has scientists truly baffled. As they continued analyzing the data, they found something that shouldn't be possible, something that defied every known law of astrophysics. The explosion didn't just happen and fade away like a typical supernova or gamma-ray burst. Instead, it left behind an energy signature that was repeating. At first, they thought it was a mistake, a glitch in the system. But when multiple telescopes confirmed it, the realization hit. This wasn't just a single explosion. It was pulsing, The residual energy was fluctuating in precise rhythmic intervals, as if something was still there, feeding off the raw power of the blast. Dr. Elias Navarro, who initially proposed the black hole collision theory, now hesitated. "Something about this doesn't add up," he admitted. "If this were just a hypernova or black hole merger, we wouldn't see this kind of structured energy signature. It's almost as if..." He trailed off, unwilling to say what was on everyone's mind, because if natural cosmic explosions don't behave like this, then what does? One radical theory now gaining traction is that this wasn't just an explosion. It was an event of unknown origin, possibly triggered by something artificial. Some believe it could be evidence of an ancient cosmic weapon, a doomsday device capable of erasing entire galaxies. Others suggest it could be the remnants of a Type 3 civilization, a civilization so advanced that it has harnessed the full power of its galaxy, possibly even capable of manipulating black holes and dark energy itself. And then there's the most unsettling theory of all. What if this explosion wasn't the end of something, but the beginning? What if, instead of destruction, this was a creation event, something forming out of the ashes of the old universe? If that's the case, then the real question isn't what caused the explosion, it's who caused it. And more importantly, are they still out there? So what does this mean for our understanding of the universe? Is this explosion just an incredibly rare cosmic event? Or is it evidence of something far more mysterious, something we were never meant to see? The discovery has left scientists with more questions than answers, and for now, all we can do is watch, wait, and try to understand the forces at play in the vast, untamed cosmos. One thing is certain: space is far more violent, unpredictable, and enigmatic than we ever imagined. If such an explosion can wipe out an entire galaxy in an instant, what other forces are lurking out there beyond the reach of our telescopes? And perhaps the most chilling question of all: if this wasn't just a natural event, then who or what caused it? What do you think? Could this be the result of a natural cosmic disaster? Or is there something else at play? Something we've only begun to uncover? Let me know in the comments below. And if you want to keep up with the most mind-blowing discoveries in space, don't forget to subscribe. The universe is full of secrets. Let's explore them together.